everyone! Kumusta? I am Cindy Sabordo from BSE 2B Science of Central Bicol State University of Agriculture, Pili Campus, introducing you to our segment, Learning and Fluid Mechanics. To begin with, let us talk about the gas laws first.
Gas laws are an analysis of behavior of gases. The variables of state like the pressure, volume, and temperature of a gas depict its true nature. Hence, gas laws are relations between these variables.
There are four general laws that relate the basic characteristic properties of gases to each other, and each law is titled by its discoverer.
Boyle's Law by Robert Boyle. Charles' Law by Jacques Charles. Gay-Lussac's Law by Joseph Louis Gay-Lussac, and Avogadro's Law by Amadeo Avogadro.
In today's video, we are going to study and focus on Charles's law.
In the late 1700s, French physicist Jacques Charles studied the effect of temperature on the volume of a gas at constant pressure. Charles' law states that the volume of a given mass of gas varies directly with the absolute temperature of the gas when pressure is kept constant. So the formula for Charles' law is V1 over T1 is equal to V2 over T2, where V1 is the first or initial volume, T1 is the first or initial temperature, V2 is the second or final volume, and T2 is the second or final temperature.
In order to understand further the concept of Charles' law, let us try solving this problem.
A 600 ml sample of nitrogen is heated from 27 degrees Celsius to 77 degrees Celsius at constant pressure. What is the final volume?
Just to recall, Charles' law is concerned about the
Direct proportional relationship
between volume and temperature. And earlier, we learned that the formula for Charles' law is V1 over T1 equals V2 over T2. And we have to cross multiply this in order to get the final equation, which is V1 T2 equals V2 T1.
So going back to solving the problem, note that in every gas law equation, we must always segregate the final and the initial so that we can substitute correctly the variable. So the initial volume here is 600 ml. And it is heated from 27 degrees Celsius. This is the initial temperature. Now note again here that temperature unit in all gas laws, in every gas laws, has to be converted into Kelvin before substituting. So in converting this to Kelvin, we just need to add 273.15. And that would equate to 300.15 in Kelvin. This is now the initial temperature. Now doing the same with the final temperature. So add the 273.15 to 77 degrees Celsius, and we will get 350.15 and Kelvin. This is now the final temperature. So we are now ready to look for the final volume. which is asked in the problem. So to solve for the final volume, the equation we will use for this is V2 is equal to V1 T2 over T1. Now you may ask, how did we get this equation? Earlier, we said that the final equation to be used is V1 T2 is equal to V2 T1. Now we have to divide both sides by T1 in order to remove this, because obviously we're looking for the final volume. So this is now the equation we will use, and this is how we get the V2, or how we got the V2 is equal to V1 T2 over T1. Now we are ready to substitute and solve for the problem. So this is 600 ml times the final temperature, which is 350.15 Kelvin, over the initial temperature, which is 300.15 Kelvin. So putting this up on calculator, solving for this, computing for the final answer, we will get 699.95 ml of nitrogen gas. This is now the final volume. This is the final answer.
So again, one of the most important thing to remember about Charles' law is that the unit of temperature must always be converted into Kelvin before substituting it to the equation, because that is the default unit of temperature in any equation in every gas law. So it is important to convert it before starting to solve the problem. So that's it for today's video. I hope you learned something, and thank you for listening. Goodbye.